blank slate. This is my binary storage that I built in Minecraft. First, I'll be showing you what it does, how to work it, and then how it works and how it stores the data. So, first of all, there's 3 data banks, and you can toggle which one you want to write your data to. Each data bank has 6 bits, which you can write data to, each one. Each bit has a on and off state, so yeah. Say I want to write to data bank 1, I flip the switch for data bank 1. And then this is the last bit in the data bank, and this is the first bit in the data bank. So let's say I want to write 1, 1, 0, 1, 1, 0. So since data bank 1 is selected, I can click the write data button, and what I wrote shows up here. When I turn it off, it goes away. This shows the data that's in the data bank you have selected on this panel. So say I were to select data bank 2, there's nothing there, so it doesn't show up. If I were to select data bank 3, nothing shows up. But only data bank 1 doesn't show what we had stored earlier. So far we have 110110. So let's write to data bank 2. 01101. We click write. 01101. Even if we switch back to data bank 1, it still shows the correct data for the data bank we have selected. Switch back. Shows the data for that one. So now let's write to data bank 3. 101101. Write data. So each individual one has a different binary code stored. As you can see here, it's all saved. And these aren't just one-use things. So say you want to put something new in data bank 1. Once it's like selected, you can press the clear selected data bank, and it'll clear it. See, now it's 0, 0, 0, 0, 0. And as you can see, actually, I don't want to show that yet. And as you can see, if I were to turn on data bank 1, 0, 0, 0, 0, 0, 0, data bank 2, still shows that. It didn't clear these 2. It keeps the data for them. So say I wanted to clear this one as well. I have it cleared. And then let's clear data bank 3 as well. Let's turn these off so I can have a blank slate. And all of them now read 0, 0, 0, 0, 0, 0. Even if I were to turn them all on, which shows the data for every single one overlaid on top of each other, it'll still be 0, 0, 0, 0, 0, 0 since they're all empty. Or 0 in binary. So, it's not a good idea to clear data while several are selected, since it'll just like wonky up all of the data that you have and won't clear them. It's just weird. So, now I guess I have to show you how it works. So first, you got to select your data bank. This sends a redstone signal to the certain signal that you selected. The signal travels there, and then it heads up this glass tower, activating all these pistons, and then it activates this redstone line here I'll show you later. This is for data bank 3, this line. It'll extend this piston, completing the circuit and completing the circuit on all of these, allowing data to be written to each of the bits in that data bank. So if I were to switch on data bank 3 and go check out over here, all of these pistons are extended. So if you take a look here, you'll notice it sends signals down this line as well. that extends these pistons to allow circuits to complete for something else that I'll show you in a sec, but it's quite important for viewing the data and resetting the data. If you were to switch to data bank 2, you'll notice these pistons extended, and these ones down here, that's the wrong ones, these ones down here extended as well. So if we were to do data bank 1, you'd expect these pistons to extend, which they do. And same with those pistons that go down, and yeah. So you might have noticed that when you write data to a data bank, you'll notice that these pistons extend. The pistons for the ones that you selected, despite whatever data bank you're using. That's because they extend, and that sends a zero-tick pulse. This is a zero-tick pulse generator, and it sends it down this line. If you were to have every single data bank selected, then it would write to every single data bank for the bits. And you don't want that unless you want copies, or you want to screw up the data that's already in them. And that's what these are for, to complete the circuit to allow the bits to be written. So say you wanted to send data to a bit. You select the bit you want to be written. You select what you want to be written, so 000011. That's what I'm writing now. Notice that these two go out for 00011 is a tier. Bit 1, bit 2, bit 3, bit 4, bit 5, bit 6. So notice bit 5 and 6 got written as a 1. So if I go take a look, redstone signal travel along these two lines. One of the signals went here. Since this piston got zero-ticked by that zero-tick generator over there, it spit out its two blocks, and now the redstone signal can travel through this slime block. And this one also spit out its block, but these four didn't, even though they're part of the same data bank. So how do you revert it back to a 0? Go over here. Since these two are selected, I'll just write the data again. Since these are selected, as it'll just revert them back to normal, since it just kind of switches the state based on what you have clicked, but it's recommended you click the reset switch instead of that. It's a lot easier. But now you notice they're both back in the 0 position, and redstone can't travel through glass. So if you go back over, as it says 0, 0, 0, 0, 0. You can also see these pistons down here. When this certain data bank is selected, and if something's written to it, you notice the 2 for those 2 bits, while it's selected, are extended. If you go back over here, deselect it, they went back. They went back to normal. Select it again, they're out. So you go take a look. The 0s are not extended, and the 1s are extended. So we're going to go back to this line that for the selected one, how these go down, the selected one is this one, yep. So they go down, which allows the signal for the 1 to travel through this block and onto this redstone line. The selected blocks always go down, which allows the signal to travel through. Signal travels to this one, or these two, since it's 0, 0, 0, 1, 1, 0, and it goes into this repeater. And that's important later. But they also, since this is extended, it travels up this redstone line here and onto these different spider leg things, I don't know. But the signal travels down these and over to the visualizer, the data visualizer, so you can see what's going on in that one. So that's how it can tell what bits are 0s and what bits are 1s. But this is also important for the reset switch. That's what this repeater is for. That's how the reset switch knows which bits to flip. So you see how this redstone line goes into here and lets this extend up. So if you were to click the reset switch, you'll notice while this one's selected, they went back to 0, and these pistons retracted since they're no longer 1s. But when they are extended, that's how the system knows what is 1 and what is 0. So it allows the signal to travel through here. When you click the reset switch, this block pops up, allowing the signal to travel through here and onto this line, one of these lines for each bit. And then it heads over here. It sends the signal into the 0 ticker, which flips the switch that it sent the signal to, and it knows which one to send the signal to because it's on and it's a 1. So if we were to write them again, as you can see, they're back out, which allows the signal to go through here. This pops up. So say we were to, I can't click it from here, but this is basically what happens. The block goes up, got reset, since the block just pops up normally. As you can see, the bit over here, it came back to normal. So that is my storage system thing. Thanks for watching, I guess. Bye.